Hello people, this is all about fractions. Now this is ostensibly about how to add fractions. I'm going to teach you how to add fractions here, but I think it's smart to go back a step and to just make sure that you understand what fractions actually are and what they're telling you. This is something that a lot of people can't actually answer the question. Right? What are fractions telling you? I'm just going to walk you through something here, and I apologize if it insults your intelligence, but I'm going to go as fast as I can, okay? So this is going to go back to sort of primary school level here. So that's a whole thing, right? Fractions are always telling you about something that's been broken into pieces. So here's a thing, whatever the heck it is, right? It's been broken into 4 pieces, right? And we've got one of them. And so that's 1/4. Right? That's easy enough. Like I said, I'm going to go through this very quickly because you know this already, but I'm just putting you in the right frame of mind. I'm not expecting that I'm teaching you anything at the moment, of course. Right? Same deal again. There's a whole piece. This has been chopped into thirds, into 3 pieces. We've got 2 of them, so the fraction that represents that is 2/3. Right? One more. There's another shape. It's been busted into 7 equal parts. We've got 4 of them, 4/7. Right? So this is what fractions are telling you. Right? Those 2 numbers are an extreme shortcut, right? Maths people are always very good at making shortcuts. Everything is written in the shortest way possible. It's almost the opposite of science, where they tend to choose the biggest words they can find to tell you about something simple. Maths chooses the shortest way they can find to tell you something complicated. A fraction tells you this. The bottom number tells you how many pieces has something been chopped into, and the top number says how many do you have, right? This is how many pieces there are and how many of them do I have. That's what a fraction is. Right? It's a quick way to show how much of what was once a whole thing do you now possess. Now a quick word about equivalent fractions, because 3/4 can be written in a lot of different ways. It can, 6/8 is the same as 3/4, 9/12, excuse me, 30/40. But without drawing shapes, how do you tell if 2 fractions are the same? All right. So I've just drawn this. Right. Again, this is 1/4, one thing chopped into 4 pieces. We've got one of them, 1/4. But I could also have started with the same thing, chopped it into 8 pieces. And if I grab 2 of those, that's the same size as my 1/4 piece, right? Again, I know that you realize this already. I'm just putting you in the right frame of mind for adding fractions, because all of this knowledge is necessary before you can start adding fractions up. All right. So 1/4 and 2/8 is the same. But without drawing the shapes, is there a quick way for you to figure out that they're the same? Yeah, there is. If you can multiply the top number and the bottom number by the same thing to get this, or if you can divide them by the same thing to get this, then the 2 fractions are the same. Right? So 1 times 2 is 2. 4 times 2 is 8. They've done the same thing to the top and the bottom to get that. Right? So if I multiplied all of those by 3, right? 1 times 3 is 3, 4 times 3 is 12. 3/12 would be the same as 1/4. If I chopped that into 12 equal bits, they'd be even smaller, but if I grabbed 3 of them, it'd be the same size as that. Right? You can multiply this by anything. Let's multiply it by 7. 1/7 is 7. 4 7s are 28. So if I chopped something into 28 pieces and got 7 of them, I'd have 1/4 of it. Right? Same deal. So you don't have to worry about using all these shapes. As long as you start with a fraction and you change the top number and the bottom number by multiplying it or dividing it by the same amount, you've still got the same fraction. So you can go backwards here. 7, if I divide both of those by 7, 7 divided by 7 is 1, 28 divided by 7 is 4, so 7/28 is 1/4, which we knew. So you can do this in both directions. Right? But that's how to tell the 2 fractions that are using different numbers are actually saying the same thing. Right? That and that are exactly the same size. Okay, all of that you know. Now we're on to adding fractions. This is what we're here for. Now because the bottom number of a fraction tells you what it is, there's a rule about when you can add fractions and when you can't. You can only add them if the bottom numbers are the same. For example, remember these? That's 1/4 from that last picture that first picture that I gave you when I broke the red circle into 4 pieces. That's 1/3 from when I break the black circle into 3 pieces. Can you add those? Right. That's a quarter, that's a third. Does that equal 2 quarters? No, it doesn't. It's bigger than 2 quarters because that's bigger than a quarter. Does it equal 2/3? No, it doesn't because that's smaller than a third. So how do you say the answer to that question? How much of a whole circle do I now have? Right? You can't directly add them together if their numbers are different at the bottom. So that's 1/4 and 1/3. And as long as those are different, you cannot add them together. You have to make them the same. So this is the problem. But there is a reasonably easy solution, because just like I divided the circle into 4 pieces and into 3 pieces, you can divide it into other amounts as well. You can divide it into 12 pieces, for example. Now, it just so happens, like we said, 1/4, how many twelfths would that be? Like I said just before, you multiply the top and the bottom by the same amount, you'll get the same size fraction. 4 times 3 is 12. 1 times 3 is 3. So 3/12 is a quarter. There you go. So that there is a quarter of that circle, and that's 3/12, right? This has been divided into 12 pieces. Right. If you did the same thing with a third, 1/3 equals how many twelfths? 3 times 4 is 12. 1 times 4 is 4. So 4/12 would be a third. Right. Now you can add it, because now it's in a different language. This is now 3/12 plus 4/12. If you got 3 of those and you put another 4 of those, 3 plus 4 is 7. You don't add the bottom. You don't say 7/24. You don't say 12 plus 12 is 24. Right? Keep in mind that bottom number just tells you what you've got. We are counting twelfths today. There's 3. There's another 4. We've got 7 of the same thing. Right? 3 of those plus 4 of those makes 7 of those. That's how you add fractions. It's this part here where people try to change fractions into being the same denominator. That's the tricky bit, right? So having seen that with pictures, I'm going to do it without pictures now. Okay, without the pictures. 1/4 plus 1/3. Here you go. This is exactly how to do this. 3 steps. The first step is find a common denominator. Get that number on the bottom being the same. That's the numerator. That's the denominator. It just means top and bottom. I don't know why they didn't just say top and bottom number, but I wasn't there. Okay. So this is going to equal some other fraction plus some other fraction, and that fraction is going to be the same size as a quarter, and that's going to be the same size as a third, but we've just got to write them differently to get the bottom number the same. So how did I know that 12s would work before? When I drew that thing, here it is. When I drew this, how did I know that 12 would work? Because I did know. I didn't chop this into 11 parts or 9 or 15 or something. I did 12. I knew that 3/12 was a quarter, and I knew that 4/12 was a third. I didn't choose tenths or ninths or something. I went 12ths. How did I know? Here's how to find out. So without having circles and stuff, how do you look at those two numbers and go, well, what other number should I turn them into? Here's how you do it. We've been teaching you about highest common factors and lowest common multiples. You need to find the lowest common multiple of these two numbers. One bigger number, it's always bigger than one of them. It's probably bigger than both of them. It's always a big number compared to what you've got, that both of these go into. One bigger number that can be divided by both of these. Now you can use any bigger number that could be divided by both of these. So you could use, for example, 120, right? Because 120 can be divided by 4 or it can be divided by 3. But why would you use a big number like that when you can use a smaller number like 12 or 18 or something, right? So you try to pick the smallest number that you can, right? You don't want these numbers to get big because you're just going to have to be adding them up and multiplying them and doing things with them. So you may as well keep it easy for yourself. Right, so the lowest common multiples. Quick way to find out what it is. I tend to pick the bigger of the two numbers. I'm going to pick 4, and I just write multiples of 4. 4, 8, 12, 16, 20, just on a scrap piece of paper somewhere. This is my working. I don't even show the teacher this, right? One of those can be divided by 3. Can that be divided by 3? No. Can that be divided by 3? 3, 6, 9. No. That can. 3, 6, 9, 12. Good. That can be divided by 3. So that's the number. That's the lowest common multiple. You know that all of those are multiples of 4. That one's also a multiple of 3. Got it. So we're going to use 12. And that is how I figured out to draw that circle, that green circle, and cut it into 12ths. This is what I did. So having changed the bottom number, got to change the top number. And again, whatever we do to that to make this, we have to do to that to make this. All right. So 4 times what is 12? 4 times 3 is 12. So 1 times 3 is 3. Right. I've done the same thing to the bottom that I did to the top. 3 times 4 is 12. So I'm multiplying by 4 here. 1 times 4 is 4. Right. So I found the common denominator. That's 12. The second is change the numerator. I've just done that. Right. So finally, add them up. And again, you only add up the top. 3 plus 4 is 7. Leave the bottom the same. Answer. That's it. All right. The hard part is the first part, right? This is the new weird bit here, turning the 4 and the 3 into a 12 and knowing that that's the number to pick. Right? Once you've got that number right, the rest of it's pretty straightforward. Now, I've just shown it to you the slow way. I'm just going to do 3 more in front of you at full pace. I'm just going to race through them at my normal pace. And you can pause the video, you can slow it if you want, but it's just so that you can see other ones done. I'm going to talk you through it, but I'm going to go pretty fast this time, okay? Right, hang on. Here's 3 of them. Might be worth hanging around for this one, by the way, because it's 1 2/5 plus 3 1/3. What do you do when there's big numbers there as well? We'll get to that in a second. But firstly, just going to quickly go through these. Sorry about the sound effects. Okay. Step 1, find a common denominator, 6 and 8. Okay, I'm going to pick the biggest one. So 8, 16, 24, 32. Hopefully one of those can be divided by 6. Nope, nope, yep. 6 4s are 24. So that equals, and I'm going to do this again, and there are 24s down there. Right, 6 times 4 is 24. 3 times 4 is 12. 8 times 3 is 24. 2 times 3 is 6. Add them together at the top. 12 plus 6 is 18. 18 24ths. Ta-da! That's it. That was about 30 seconds. Right, try this one. Another one. Right, I'm going to pick the big number, 5s. 5, 10, 15, 20. Normally you go about 4 or 5 of them and that's enough. Right, sometimes you have to go way down here. Normally it's not. That's enough. Rightio. Which one of them can be divided by 4? Can't divide that by 4. No, no, yes. 4 times 5 is 20. 4, 8, 12, 16, 20. Gotcha. Right. So these are going to be 20s plus 20. 5 times 4 is 20. 4 times 4 is 16. Doing the same thing to the top and the bottom. 4 times 5 is 20. 3 times 5 is 15. That 16 plus 15 is 31. 31 20ths. If you want, now that's the answer. You are finished there, by the way. If you want, you can do this. This is optional. Unless the question says you have to do this, it's optional. But some people, because that's an improper fraction, the top number is bigger than the bottom one, they convert it to 1 and 11 20ths. Right? Because 20 20ths, when you got the same number on the top and the bottom, that means 1. Right? 4 quarters is 1, 5/5 is 1, 20 20ths is 1. So we've got at least 20 20ths. So we've got 1, and we've got 11 more than 20. So that's why it's 1 and it's 11 20ths. Those 2 bits add up to 31 20ths. All right. This one. Excuse me. Let's have a look at this. Get it in the middle of the screen for a second. There are 2 ways to attack this. I'm going to show you both. I'm going to show you the one that I think is the easiest, shortest, quickest way to do it. I'm all about doing things the easy way. So the quickest way to do it, I think, is to treat the whole numbers and the fractions differently. Right? Treat them separately. Right? So firstly, number 1, add the whole numbers. 1 plus 3 equals 4. Let's just keep that in mind later on. So that's the 1 and the 3 out of the way. Step 2, I'm going to color coordinate it here, add the fractions. Now we'll come back to that 4 in a minute. Right? We're just going to leave that there for a minute. We're going to add the fractions now. So forget the 1, forget the 3, we've dealt with that. It's now just 2/5 plus 1/3, and we've got to do all this stuff for here. So I'm just going to really quickly do this. 15 is the lowest common multiple for that. I'm not even going to show you how I work that out. 5 3s are 15, 2 3s are 6, 3 5s are 15, 1 5 is 5. So that's 6 plus 5 is 11, 11/15. So the total answer, remember we've got this 4 here, right? So the answer for the whole thing is 4 and 11/15. Ta-da! Right? That's the short way. I reckon that's the easiest way to do it, but there is another way, right? And you might be forced to do this way sometimes, so I'm going to show it to you anyway. So here it is again. I'm just going to write the same question. 1 and 2/5 plus 3 and 1/3. Okay, we're going to get rid of that. So here it is again. Every now and then a question like this turns up and they say, turn it into improper fractions and then add it. Okay, so if they say to do this, then this is what you've got to do. You've got to get rid of this and turn that into fifths as well and add it together, right? Now 1, of course, is 5/5, and that's 2/5. So 5/5 plus 2/5 is 7/5. Right? So that is actually 7/5 plus, same thing here. 1, if that was a 1, that'd be 3/3. Now 3 must be 3 times 3/3, which is 9/3. Right? And that's 1 more third, so that'd be 10/3. The quick way to do this, the sort of surefire, non-thinking way to do this is to multiply the two numbers that are on the ground together and then add that one. 3 times 3 is 9, 9 plus 1 is 10. 10/3. Right? Works with this one as well. Multiply the two numbers that are on the ground. 1 times 5 is 5, 5 plus 2 is 7. Ta-da! Right? So, turning it into improper fractions. Then adding. Okay, so now we're doing the same thing we did again. So, going to turn it into common things. 5 3 15 is the lowest common multiple, right? 5, 10, 15. Can't be divided by 3, can't be divided by 3, can be divided by 3. That's why I did that. Right. 5 times 3 is 15. 7 times 3 is 21. 3 times 5 is 15. 10 times 5 is 50. Add the top ones. 21 plus 50 is 71. So we've got 71/15. Now, what answer did I get before? I got 4 and 11/15, if you remember, right? So the answer to that, to the same question, the first way, let me show you. There it was, right? Same question. You saw me copy it, 4 and 11/15. Now here, I've got 71/15. I'm going to show you that I do the same thing. Okay. So 15ths. So 15/15 is 1, right? So every 15 I've got in there is actually 1, right? So multiples of 15, they go like this. 15, 30, 45, 60, 75, 90. They're multiples of 15, okay? So I've got 71 of them, so that's sort of there, between 60 and 75. So I've got 1, 2, 3, 4 15ths. Oh, sorry, 4 is 60/15. But 71 is 11 more than 60. So I've got 11 more 15ths left over. And sure enough, that's the same answer. So it does work, right? 4 and 11/15, 4 and 11/15. This is definitely the long way, and you get bigger numbers that you've got to deal with. I think that's the harder way to do it. Sometimes you'll be told that you have to do it that way anyway. They will say, convert these numbers to improper fractions. An improper fraction is one with a bigger number on top than on the bottom, because you normally don't see that, right? And then add. If they tell you to do that, you've got to do it the long way. But I think if you have the choice, if they just give it to you and say, answer it, this is the way I would go. Right? Add the big numbers, keep that out of the way for a second, add the fractions by themselves, put the two answers together. Easy. All right, that is Adding Fractions 101.